In this video of the StreamSets loosely coupled architecture, we'll look at the main pipeline. Here is the original completed complex pipeline. Before we go through the pipeline and show what it does in detail, let's ensure there's a data collector assigned. 0D5. That's what we have currently running in our Strigo environment, 0D5. This will vary depending upon your deployment you've set up. I want to read the data from an API call as a call from StreamSets, and I want to write some of the data to various MySQL tables, and maybe other destinations in the future as well. This will be prone to bottleneck failures if databases are down, if the API call is down, and so on. Let's do a simple curl call to show the data that we're going to retrieve from this API call. So here's the API call. And you can see the data that we are retrieving consists of a domain, a create date, an update date, a country, and various other bits of data. We're only interested in the domain, the create date, and the country. So I can filter out those values from the curl call like this. We're filtering out domain, create date, and country. And that's what we'll see. You'll notice some of the countries have null, and some of them have values. So our pipeline will be retrieving the data from the API call. It will be pivoting that data and transposing it so that it's more than one record, because when it's read from the HTTP client, it'll just be one record. We're then flattening all the data. We're renaming some of the data. And we're removing some of the data, or actually keeping various fields. And as you can see, we've got domain, create date, and country. And then we just have a stream selector at the end that will filter out which countries are null and which ones are not. It will then send the appropriate values to different tables in a MySQL database. So let's look in a bit more detail. Here's our HTTP client. There is our API call. We've got field pivoter, and we're pivoting on the /domains field. We're flattening the data, flattening the entire record. We are renaming some of the data, and we're removing the domains dot from all of the fields, and as said, we're keeping those fields on display there, and then filtering out with that stream selector. The two tables at the end of the pipeline are defined as follows. We have null country, and this is just the JDBC link using an appropriate connection of type JDBC. The table name is country null. Let's look at the details of the connection we might create. Under Setup Connections, edit your connection, for example, myJDBC or mycredcon or whatever you called it. Ensure your latest data collector is selected. We can see that the type is JDBC. It uses this connection string. This will rely on the JDBC driver that was placed inside the data collector. If we test the connection, we can see that we get a green tick. Back on the pipeline, we have country null uses the mycredcon connection. Similarly, country not null also uses the same connection. Let's preview the pipeline. But before we do that, we need to create the two tables, country null and country not null, in the MySQL database. We can do that with two create table commands. Back in Strigo, we need to look at the MySQL database. So we first go into the container hosting MySQL. Type sudo docker exec -it mysqldb bash. Then we need to go into the MySQL database within this container. So type mysql -u root -p. Then enter the password. We're going to use the classic models database. Then we're going to put in our two table creation commands. We're creating a table called country not null, and this will have the fields domain, create date, and country, and similarly a country null table. That will have the same fields in there. Now let's do a preview on the pipeline. Here is the domains field, and you can see each one of these records has a domain in there. So we're pivoting on that, and each one of those gets turned into a record. We're then flattening that record. Each of the domains hierarchy has been placed in front of its field name. So we have domains.createDate, domains.updateDate, domains.country, and so on. Field renamer actually removes that domains dot in front of those fields. Field remover, or keeper, as in our case, we're keeping the domain field, the createDate field, and the country field. We're then filtering out at the end all the records that have a country of null and a country of not null. You can see some of them satisfying condition 1 and some satisfying condition 2. Here we see an example of a condition 2 which has a value for the country. Here's an example of condition 1 which has a null for the country. So, although we're not writing to these tables on this preview, we do have to have the tables created, but our preview will not populate the tables. Back in Strigo, we typed select star from country not null. It should be an empty table. We'll now run the pipeline. Notice that the pipeline automatically finishes. Let's check in the MySQL database that the two tables have been populated now. So we'll say, select star from country not null. Also, country null. Today, we can see we've got 17 rows in the country not null, and we've got 33 rows in the country null table. For this particular API, these values can vary from day to day. Let's see what happens when the MySQL database is down, when we try to run the pipeline again. If we stop the MySQL container in our lab environment, this will cause an issue in our pipeline destination, and this will highlight the dependency. So let's stop the MySQL container and do a quick check to ensure it's no longer running. We can see MySQL DB, the container has stopped. Make sure again, in case of any auto restart, it is still stopped. We'll try running the pipeline again. This time we get an error, cannot connect to the specified database. Last packet sent successfully to the server was 0 milliseconds ago. This shows we can't connect to the MySQL database, so the successful running of this pipeline has a dependency on that MySQL database, and any other destinations being placed within this pipeline may also not be written to because of this error. So we're trying to take out that dependency. This will keep retrying for as long as it's configured to do so. Let's stop this pipeline. Let's restart the SQL database. We'll now introduce a new destination onto the pipeline, an Amazon S3 bucket. If you'll add stage, Amazon S3 for the destination. Connect the output from the first stream into the Amazon S3 bucket, as well as the country null table. Let's just configure that. So the same data that is sent to the country null table in the MySQL database, we'll write to the Amazon S3 bucket, and we'll just do it in JSON format. If we have a look at the Amazon S3 bucket, we can see we don't have any kind of null country file in there. So let's run the pipeline. The pipeline has now finished. If we have a look in Amazon S3 and refresh, we can see that we do have a null country entry in there. We will still have the entries in the country null table and the country not null table within MySQL as before. Now we'll shut down the MySQL database and rerun the pipeline. As before, we get the error saying, cannot connect to the specified database when trying to write the data to these two tables. However, this is additionally stopping the data from being written to the Amazon S3 bucket. When we refresh our Amazon S3 bucket, we still only have the one file in there from earlier. No new file has been created. So the fact is that the database is down, and it is causing a bottleneck for any other destination. And that's why we need to loosely couple the architecture. Now let's create individual pipelines based on this complex pipeline that are more independent and not so tightly coupled. Thanks for watching.